Hey everyone, welcome to video 2. We're going to go ahead and get right into this example. Find the volume of the wetting band obtained by rotating the region between the graphs of f of x equals x squared plus 2 and g of x equals 4 minus x squared about the horizontal line y equals negative 3. So, first thing you want to do is you want to find big R of x and little r of x. We're rotating about the line y equals negative 3, so it's drawn in black there. So first thing I want to do is draw a line from what I'm rotating around to the graphs. And the longest line, the graph I get to last, that's going to be my big R of x. That's the outer radius. It's the longer of the two. So to find the length here, I take top minus bottom function. So that becomes 4 minus x squared minus negative 3. So I end up with 7 minus x squared. So that's big R of x. Little r of x is if I draw my line, a vertical line, vertical line from the axis or the line I'm rotating about to the shorter of the two graphs, okay, that's little r, okay? So little r of x is going to be that top function minus bottom. So top function is x squared plus 2. Bottom function is negative 3. So I get x squared plus 5. So I've got my R of x and my big R of x. So here's my intersection point. So there's my lower and upper limit of integration. So I go volume is equal to pi times from negative 1 to 1 of big R of x, which is 7 minus x squared, squared minus little r of x, which is x squared plus 5, and that's squared as well. Now, if you have a calculator, this is where it's handy to use your second pi math 9, and I've gone ahead and I've already done that above, but I could go ahead and say math 9 now, and I can do my integral from negative 1 to 1, okay, and I strongly suggest this, 7 minus x squared, if you're allowed to do this, because the algebra can get a little tricky. So I plug in my function, x squared plus 5 is my little r of x, I square that. Hopefully I did everything right with the buttons, didn't miss anything, and it looks like I get 100.531 as the volume. But if I did that by hand, okay, it can get a little tricky. And so what I can do here is I can square this stuff out. Okay, so I have pi goes from negative 1 to 1. And when I expand 7 minus x squared, I get x to the 4th minus 14x squared plus 49 minus, then I got to expand x squared plus 5. And when I do that, I get x to the 4th plus 10x squared plus 25. And that's all integrating with respect to x. By combining like terms, I can go from negative 1 to 1, and I get negative 24x squared plus 24. All dx. We can go ahead now and integrate. So I get 24x minus 8x cubed. Okay, I switch those, but I go from negative 1 to 1. Plugging those in, I end up getting 32 pi. So when I plug 1 in and then negative 1, okay, I end up with 32, and I multiply that by pi. Okay, so one more example. And here is where we go around the vertical line. So our equation is volume equals pi times the integral from c to d of big R of y squared minus little r of y squared. And that's dy. So the first thing you probably want to do, and not forget, is solve your equation. Y equals 4 minus x squared for x. So we're rotating between 0 and 2 of 4 minus x squared, so I minus 4, so I have y minus 4 equals negative x squared. Switch the signs, so I get 4 minus y equals x squared. So I have the square root now of 4 minus y equals x. So that's really important. So now let's go ahead and find our big R of y and little r of y. So from the line we're rotating about, we draw a line horizontally. Remember, these lines drawn horizontally are perpendicular to what we're rotating about. So here's big R of y. And that, remember now, this time it's your right function minus your left. So big R of y is going to be equal to the square root of 4 minus y minus negative 2. Okay? This should be a negative 2. I don't know if you can see that. And that gives me the square root of 4 minus y plus 2. Okay, there's big R of y. Little r of y now is just from here to the vertical axes. There's little r. So that's 0 minus negative 2, which becomes 0 minus negative 2, which becomes 2. Now, let's go ahead and set up the integral. So I have pi going from, what's my limits? I'm going vertically here from 0 to 4. Okay, limits of integration. And then big R of y is the square root of 4 minus y plus 2 squared. And then little r of y, you're minusing 2 squared, which is 4 dy. Now let's go ahead and use the calculator to get this. Okay, so we're going to go ahead and do pi. Well, we're not going to have pi. We're going to have second pi times. So I'm going to pretend this is x. Okay, so math 9. I'm going to go from 0 to 4. Okay, and I'm going to do the square root of 4 minus x. Okay, plus 2. Close it off, square it, minus 4. That's already squared, so be careful, and we'll go with respect to x. So the calculator doesn't care. I know it's with respect to y. It doesn't really care. Okay, you just have to make sure the limits of integration are set up. So I go ahead and hit enter, and it should spit something back to me momentarily if it likes that. So I get 92.153. So 92.153 for the volume. I chose to just use the calculator because that can be a little bit of a pain to integrate. Okay, so that's a couple more examples of finding the volume revolving around the line other than the axes, the x or the y axis. So if you have any questions or comments, go ahead and type them below, and we'll see you next time.